I'm going to have to draw these pictures, so they're not going to be as beautiful as I want them to be. So I'm going to try to make them so that you understand what I'm doing. So we're going to find domain and range from a graph. We just talked about are they functions or not. Now we're going to talk about how do you find a domain and range from a graph. There is, hold on one second. I can make a grid on my paper. I just deleted that, didn't I? Do you see the grid paper? I'm gonna write again. I'm gonna need the grid paper to draw. How to find the domain and range from a graph. Remembering that domain is your X values and Y are your range. Now, when we find domain and range, we're going to write it in interval notation, just like we did last time we met, except we didn't do it for graphs. Okay, that didn't come out too bad. Okay, do your little picture as close as you can get. The most important thing is where it ends. The ends are what's important for this graph. And then write domain and range under it. And I have a little hint for you on how to do domain and range of a graph a little bit easier than what it's going to be. Okay, so it's not bad. I don't make it sound bad. It's not bad, but I know a lot of students have a hard time with this. A lot. Okay, for domain, you're going to look left to right. You're going to find the smallest to largest. No, I'm taking it back. You want to find the smallest value and then largest value. So you're going to look like a book, left to right. And then you're going to look at the smallest value and the largest value. And again, I'll show you this when we do a couple graphs. Then range. You are going to look low to high, meaning down to up, but low to high. You look at the graph, the lowest point, highest point. So you're going to find the lowest point, and then you're going to find the highest point. I shouldn't say point. I'm taking point out. I don't mean point, value. And remember, range is your Y's. So when I say value for range, that means the highest and lowest Y. And if in domain are your X's, so when I say value, your lowest and highest X. If you can get used to doing this, go left to right for domain and low to high for range, you're going to be awesome. It won't take long for you to do these. Okay, so I didn't mark these. I probably should have, because we're going to need them. 2, 3, 4, 5, 6, 7, -1, -2, -3, -4, -5, -6. 1, 2, 3, 4, 5, and -1, -2, -3, -4. Okay, so let's do it. Left to right. What is my lowest, what is my smallest X value? Well, I go to my end. This one has an end, right? So my lowest, if I picked a different color, I think I did. This is my lowest X value, isn't it? -5. So does it equal -5? Yes, it has a solid point. So -5 is my smallest X value. What is my largest X value? Notice it's all continuous throughout, right? It continue. Everything's in between. So it's one of these where you have a beginning and an end. What is my largest X value? Well, that would be this point, which looks like it's at 6. And it's equal to, because it's a solid circle. So I went left, what's my smallest X? Right, what's my biggest X? And everything in between. If one of them was an open circle, I'd have a parenthesis just like we did before, but they were both solid circles. Now, I am drawing these little dashed lines because I'm not in the classroom with you. I'm just showing you what I'm looking at. You don't have to draw those dashed lines, but it's a visual for you since I'm not right in front of you going with my finger. Look, it's right here. I don't have a finger to show you, so I'm doing it with lines. Okay, now, range, low to high. What is my lowest Y? Okay, so then I gotta look at the Y axis. My lowest Y is -3, and it's a solid circle, so it's a bracket again. It's equal to -3. What is my highest Y? Well, the Y axis, this is my highest Y, and that would be 5, which is also a bracket because it's equal to. And if you do domain array like that all the time, you'll be fine. So domain, left to right, lowest to highest X, range, low to high, smallest to highest Y. All right, let's do another one. Whoops, that didn't work out. Whoops. Let's look at a parabola.
Is that a solid circle at the bottom parabola, or is it going to be open?
It's solid. It is solid. I was trying not to do a circle. I had to do a circle so I could see it. I didn't want to do a circle at all, honestly. I wanted like not so you can't see it. I tried to do it with freehand, it didn't work. So I had to put a circle to help me draw it. But normally you won't have any circle there. It'll just be a continuous graph.
So in that case, would it still be a bracket, or would it be the parenthesis?
That's why I didn't want to put a point. It's still equal to because it's going to that point, through that point. So it's definitely a bracket. Yeah, you figured out why I didn't want to do a point. Exactly why I didn't want to do a point for that reason. Okay, so now domain left to right. but we have arrows going left to right, right? So a parabola is going to get, I'm going to just draw this, I'm going to over exaggerate. It's going to get like wider and wider and wider and wider and wider as time goes on, right? It's going to keep going. It's going to go up. It's going to keep going like this, right? It's going to grow up. And it's also going to get wider. That's a parabola. It doesn't go straight up. It gets slowly gets wider and wider. So that means that there is no smallest x and there is no largest x. And that means everything is the answer, which means negative infinity to infinity. But the parabola does have an end. It's not going to go in the y direction forever. In this case, I have to go from my lowest to my highest. My lowest y is, didn't do a good job marking this, -1, -2, -3, -4. It is a solid circle because it goes through -4. So my lowest is going to be bracket -4. But what's my highest? There is no highest. It goes forever, infinity. So I see you guys stop writing and keep going. I'd like to watch your face. I'd like to watch you. I see some people done, some people are still writing. I'm going to scoot down. We're going to do 2 more graphs, domain and range. By the way, since we're here, is the first one a function?
Yes.
Is the second one a function?
No.
Yes. Yes. So you're going to do a vertical line anywhere. It's going to keep going because those lines are never going to be vertical. They're always going to slowly go out as it gets,
Yay,
as it
I
gets
feel
larger
like
and
I'm learning. I'm learning, y'all.
larger.
So
It's
earlier, I asked if parabolas were always a function. And
Yeah, they are.
Okay, never mind. You're right. I was
Yeah, yeah.
thinking, I said, okay, never mind.
You're fine. You're fine. They are functions, but a parabola on its side, which isn't called a parabola anymore, is not a function. That's actually called something else, which you'll learn eventually. But yes, all parabolas are functions. All right, I'm going to scoot down, and we're going to look at two more graphs. I like that graph. I just sort of made it up in my head.
It's shaped like a tooth.
Yeah, it's actually an x to the fourth power. If you've ever seen a fourth power graph, that's a x to the fourth power. Interesting. And you'll learn that too. I don't know, this year or next year. I'm not year. I don't think it's this class. Where I remember, it's probably next class. But anyway, a domain, left to right. What is my lowest x? I see -6, so you? But I see an open circle, so it has to be parentheses -6. What is my largest x? Well, that's all the way on the right. Remember, left to right, left to right. I went left, now I'm going right. That would be, okay, nothing I didn't even mark. I didn't even mark it. 6. Now that has a solid circle, so it'd be a bracket. Now, so we did left to right, and now we're going to do low to high. Low to high is your y's, my range. So I look at my y's. What's my lowest y? Well, I know it's also done by hand, so it's not perfect, but that they're both the same. That's my lowest y. Then my lowest y would be at -4. And since the graph is going through it, there's no open circles, it is considered solid circle. I could do a solid circle if I wanted to right there. So -4. Now, what's my highest y? Well, I'm going to go all the way up. I went low, and I'm going to go high. My high has this point right here. That's my highest y, and that happens to be at 6, and that is a solid circle. So I'm going to make that a bracket.
I don't get that. What do you mean? So like how you said you're gonna do like the brackets for the -4 because you can go through it? What, I don't really get that. Can you explain?
Sure, absolutely. So I'll do it on the side, and then I'll erase it. But let's say this is my graph, right? Anywhere on that graph, I could do a point. That's a point. That could be, where am I? -4, -4. This is a point. This could be 6, 7. So anywhere is a point on a graph. So I can do points forever. There's like infinite amount of points on a graph. They're all coordinates, right? So really this on the bottom is just a coordinate, and which makes it a solid point. Does that make sense? Like even a line, if you have a line, everything has a coordinate. Everywhere there's points on a line.
Why is the -4 at the bottom? Why is it a bracket again? I mean,
For the same reason, because the lowest point is at -4, but there's no open circles, and it's just a graph that goes through it. And if a graph goes through it, it has a point. So if I have,
So it can only be an open point like at its tips.
yes, it's only if you're gonna
Like
see an
it
open
can't be
point.
it has to be closed if it goes through, if the line goes through it.
Exactly, because there's a point
Okay.
there. Exactly.
Okay,
There's a point there.
thank you.
Yeah, you're welcome. If I put an open circle on one of those, then it'd be open. Then it would be a parentheses, not bracket. But if it's a graph that goes through something, it counts as a closed circle. It's a point. It's a good
Okay.
question. Very good question. All right, let's do one more. Oh, that was awful. Look at that line. Ooh, ooh, ooh. I'm only going to do the first quadrant. I don't know why I drew the whole graph, but so you don't have to label the negatives. Oh, no, 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 I don't want that. Change my line. I gotta do it in pieces. I can't do it one time. right, pretend it's a circle or oblong circle, which is an ellipse. Pretend is something called ellipse, but just pretend it's circular. I didn't do a very good job. But you see what I'm trying to do? Yeah, okay.
So we know this is not a function, right?
Exactly. That's why I did it. Very good. Not a function. Exactly. But it still has domain and range. It still has the lowest y's or it still has domain and range. Any graph has domain and range, no matter if it's a function or not. All right. So actually it looks like a lemon. Does it look like a lemon now that I'm looking at it? Looks like a lemon. Yeah, that's
Good
not what I
question.
wanted. Yeah,
Because
go
it's a
ahead.
continuous circle, would it be brackets because there's no end?
Yes. Yes. There's yep. Because every single, no matter where you are in that circle, I can tell you a point, a coordinate, no matter where I am. Exactly. So there's not going to be any there's no open circles. Everything counts like that. Okay. So left to right. I probably just made it worse because I did all those little points, but the left to right, what is my smallest x? Well, that would be 2. Bracket because I have no open circles. Right, what's my highest x? That would be 6. Bracket. Y, low to high. What is my lowest y? What's my smallest y? 3. Bracket. What is my highest y? I go to my top. I probably missed it a little tiny bit, but I meant to be 5. Bracket. And then you guys already answered my question I was going to ask. Is it a function or not? Nope, not a function, but it still has domain and range. Okay. They're actually sort of fun. All right, we have one more thing to talk about. This section was really long. So we have one more thing to talk about in this section. And then we're going to hit the next section. But the next section we sort of kind of already did. I sort of did it with last class. So I'm going to go over it a little bit and then that one's going to be real quick. All right, so I'm going to add a page.
Can we break for bathroom before the beginning of the next section?
Yeah, that's what we're going to do. Exactly what we're going to do. Don't worry. And if I forget, just call me out. Okay, so function notation. Whoops, I want to be black. Function notation. You've probably seen it, maybe you've used it before. So y equals 3x minus 2, that's not function notation. If I change my y to f of x, that is my function notation. And this is said f of x, that's how you say it. So my function notation is f of x. So wherever y is, I could use function notation. But the question is, why would I? We already have y. Well, there's a reason, because function notation comes in real handy. It's almost like a shortcut of things that we can do. The one thing I want you to realize that I'm not saying f times x. This is a notation for a function. So this is 1 unit. It's not like being multiplied. Whoops, that's really cool. I know I could do that. It is not being like multiplied. It is just notation. So this is just notation for a function. Now, what's nice about function notation is that they give you an equation and it has f of x in it. You don't have to ask yourself it's a function. They're telling you it's a function. So you can't use that notation unless it's a function. For instance, don't write this down, but I'm going to write it so you can see it. Don't write it down. I cannot put in place of x equals, say I have, okay, say I had x equals 8. That's not a function. I cannot go back and go, oh, well, then I'm going to write it in function notation. Nope, that's not allowed. It's not a function. You can't do that. So everything that has a function notation is a function. Now, what's it used for? Well, you know, before, like when I said, actually, you can write this down. evaluate x squared minus y when, nope, take the y out, make it 2, when x is equal to -3, something like that. Well, there's a shorthand way to write it with function notation. So I'm going to rewrite this with function notation. F of x squared minus 2 is a function, so I can put f of x equals x squared minus 2. And then I'm going to go like this. I want you to find f of -3. That's exactly what I said in blue, just said with function notation. Here is my function. I want you to find f of -3. So what it's telling you to do is that instead of x, because f of x is our function notation, I want x to be -3. So then you would do the same thing. You would take and put -3 in, and you would simplify, and you would find out that f of -3, when I put -3 in for x, I get an answer of 7. So shorthand way to say, hey, take that equation and plug in -3. What you also have, which I don't know if you ever realized if you've done this before, you also have a coordinate. That means when I put in this function, if I put -3 in my x value, I get 7 out. So I also know this coordinate is on that graph. And I can do that for anything. Now I can say, okay, find f of 0, find f of -2, find f of 7, and you will find slowly all these points on the graph, and then you could draw a picture. All right, so let's look at another one. So let's say, I'm gonna number these. If f of x is equal to 4x minus 1, find f of 2. Same thing, just written a different way. If f of x equals 4x minus 1, find f of 2. Okay, so it says take my function, and wherever x is, I want you to make it 2. That's what it's saying. So I'm going to go down here, I'm going to do f of 2 equals, so wherever x is, I put 2 in. And now I can simplify. 8 minus 1 is equal to 7. I got 7 again, how about that? Didn't realize it. So f of 2 is equal to 7, which also means that my coordinate 2, 7 is on my graph.
You don't roll 7 3 times, that's 777, girl.
I don't know. I need to go somewhere, huh? Go to the casinos. I'm never lucky. I know. How did I do that? Interesting, I know. All right, question on those two. We're gonna do a few more. Okay, I'm screening down. 2. Okay, if f of x is equal to negative x squared plus 4x minus 2, find f of -2. Would you guys like to try this one on your own? You guys are okay to try it on your own? Be careful with that negative in the front. That's my only warning. Careful with that negative in the front. Okay, I'm gonna start writing it. If you're still doing it, do it. Don't look. If you're done, take a peek. How do we do? We do all right. Okay, how we do? Good.
I think I got
Excellent.
it
Good.
lost because the two negatives was gonna equal a positive, right?
For okay,
I-
for the first part,
Uh,
for this part right here.
yeah,
one?
that's,
Okay, so that's the one I want you to be careful of. So when you have, put this on the side, minus -2 squared, remember the order of operations. You got to do your square first. So it's a negative times -2. Actually, I'm going to write it out. It's this. But I have to do order of operations first. I got to do that first. That's my square. So that makes 4. So it's -4. So you're doing -2 times -2 first, which is 4. Let me write this again. Hold on. Negative of a -2 squared. Order of operations, I got to do this first. -2 times -2 is 4, but that negative is not part of that 4. A negative is outside that 4, -4. You can't do this because that's not allowed. You got to do the square first. And that's because it's squared. It's not like just a parentheses. That makes sense? Like if you had this, yeah, that's positive. Absolutely. But if I have a square, it's not positive because I got to do this first, which is all positive, but my negative is still here. So it becomes -4. I have one more to do with you for this one. And then I have one more thing about functions I gotta tell you, and then we're done. Okay. So, oh, if f of x equals x squared minus 3x plus 1, fine. Okay, I don't have to give you a number. I can give you anything. F of y cubed. Doesn't have to be as a number. It's the same concept. It just doesn't have to be a number. Now remember, really, really important that you're only allowed to replace x with y cubed. Just x. You can't take exponents. It's just x. Okay, so what do I have to do? Wherever x is, I got to put y cubed in. But that squared is still here. That's not x. That square is different. Minus 3 times y cubed plus 1. So replace only x with y cubed, and then we're going to simplify. And really, the only thing I have to simplify is a y cubed to the second. And if you remember, when you have a power to a power, they call it, you multiply your exponents. So it'd be y to the 6 minus 3y to the third plus 1. So f of y cubed is going to equal y to the 6 minus 3y to the third plus 1. So it doesn't just have to be a numerical value. It can be a combination of numerical values and different variables. It could just be a variable.
Excuse me, I have a question.
Sure.
So how do you know X is equal to Y cubed?
Oh, it's given. Oh, how do I know it? Okay, here, I know why. I know why. I see what you got. Okay, so we are given, I'll do a side note, we're given f of x equals. So when you see f of y cubed or anything else, what they did is they took x, they're taking x out and they're replacing it with y cubed. See how they line up together? The x is on the inside and then y cubed on the inside. They're telling you take the x out and put y cubed in.
Okay.
Okay. Anything else? That's a really good question too. They're all good questions. All right. I'm going to turn a page. One more page for this section, and this section will be done. This is a long section, right? Oof. Okay, so one more thing. I'm not even going to say label it. It's still functions. So I'm going to make a graph. So let me find my graph paper. Nope. After this, we finish this lunch break. But it'll only be like 5 minutes because I'm looking at the time and I'm going, oh boy, we got an hour left. I think we could do it. I think we could do it. Okay, so this one, I got to draw by hand a little bit, but I'm going to have to use points to help me. So just know the points that I draw are for me. You're not going to see them on a picture. They're just for me to help me draw because I can't draw without doing points. Trying to make a parabola, but I have to have it in a certain spot. Okay, so I'm going to erase those points here in a minute because really you wouldn't see a point. If I can erase a point. Okay, not the best picture on my part. Okay, find each value. It's still using our function notation. So it's the same idea, but you don't have the equation. You have no equation to plug this into. You have to look at the graph. Now I'm going to add points as I show you how to do this so you can see what I'm doing. Let me label these. 1, 2, 3, 6. I got some people still writing. I know some of you are done. Just wait 1 second. Make sure everyone's with me. I remember when I was in school, I had trouble with this. It's like, what are they talking about? I don't get it. Like, I just really didn't get it. So hopefully I can explain it so you get it.
And then you became a mathematician.
Yeah, I know. I've always loved math. I actually, a lot of people are still writing. I didn't go to college from high school. I went back when I had 4 little kids at home and got all my degrees. So I always say, if I can do it, anybody can do it. Definitely. I had what, 2-year-old, a 3-year-old, a 5-year-old, and an 8-year-old when I started school. Yeah, crazy, right? Don't do what I did. Good.
I'm doing it now. I'm doing it now.
Sorry. Then I feel your plight. I did it. I remember. Boy, I remember sitting at school and not understanding it. I would sit and I work hard and I wouldn't go home because as soon as I went home, I'd be like, oh my gosh, I wouldn't be able to do anything with the kids. And yeah, I remember. I do. And I started college on a dare. My mom told me, I bet you can't do it. And I said, oh, really? Watch me. So not only did I get my associates, which is what she told me I couldn't do, I went and got my bachelor's and I got my master's and I went back for something else. And like, I think I proved her wrong 5 times over, right? I kept telling her, I'm too old to go to school. She goes, no, you're not. Yes, I'm too old to go to school. I got kids. I can't go to school. And that's what she said. I dare you. You can't. I'm like, okay, don't dare me. Nope, not going to happen. Okay, so here we go. It looks really hard and like, what are they talking about? But remember, the X is in the parentheses, right? So this saying, what this is saying, look at X equals 1. What is Y? That's what it's saying. Look at X equals 1. I'm going to do it. X is 1. What's my Y? My Y is 0. Okay, next one. Look at X equals 4. Okay, I'm gonna go to 4. 1, 2, 3, 4. I gotta find my Y. My Y is 3. So again, it's just talking about coordinates in a very different way. The next one, F of -2. X is -2, what's Y? So -2, if I go up, I am also at 3. And the last one, F of 5. So when X is 5, what is Y? So 5, I'm gonna go up and I got this one and I got 8. And that's how you do it when you don't have an equation, they just give you a graph. It means the same thing. If I plug in 1 to the graph, where's X1, you'll get what Y out. Same kind of idea. Okay, so 5-minute break, be back. Don't take longer than 5 minutes. I need a time. Take a break, get up, stretch, go to the bathroom, something. I'm gonna stand up too, I need a stretch.